Okay. Yeah. Hello, everybody. Yes. This morning I was asked a question about when something happened, and I said something, I guess, 1994, which made me realize that we have LaTeX as we have now for exactly 30 years, and probably 30 years ago, which I can't remember. My memory gets better and worse and worse. I was introducing that we have a new LaTeX version. So what I'm going to introduce now is to introduce you to my garage. I'm going to talk a little bit about hooks and later on a little bit about sockets. So what is a hook? This is an example, and what can you do with it? Well, you can put some stuff on it, as in this case the bicycle bags. So what are the characteristics of hooks, at least those in my garage? It can be empty. The first page showed picture showed this. It can hold items, and it can hold sometimes a lot of items, even if it gets crowded. And such items, you can add them to the hook. You can remove them again. You can possibly reorder them the way they are on this hook. And one other characteristic of such garage hooks is you basically store items that you possibly don't need now, but later, or never ever. They still sit there. Okay. So turning garage to what LaTeX does, the history of hooks in LaTeX. In the early LaTeX, the one that I started with 208, I think actually, but 209 is the one with the book. There were no hooks whatsoever. It was just very, very dense code, and anything that needed to change was done by patching the internal commands of the LaTeX format. When we introduced 30 years ago, we tried to make this a little bit better, and we introduced a few hooks, basically one at the beginning of the document and one at the very end of the document, and offered some possibility to add stuff there at begin document, at end document, but not much more. And there was no management. So whenever a package says add begin document, it was added to this hook, and it became one after the other. And depending on the order you put something on the hook, it was the order that was finally being executed when the hook was actually being used in some way. Now today, and today means basically I think since year, 2 years, I can't remember exactly when it was introduced, we have a general hook mechanism available. And we have hooks in many places, and the number is growing. And we can manipulate those hooks at different stages, if you like, from the outside. So you have data in the hook, you might be able to manipulate that. You can add to it in the preamble, you can add to it in packages for hooks that are in the kernel or in other packages and so on. So there is a mechanism there now. What was the problem with the two e-hooks? I already said that a bit. Here are my hook with two items, and I want to put an item in the middle, the red one, because I need the green one all the time, and the red one also often, but not that often. I can't do that with two e-hooks. We have no order, or rather we have the order in which the stuff was added to the hook, and as a result, whenever two packages were adding something to the begin document hook, they came in the order the package was loaded. And then if something didn't work, the suggestion was, oh, well, change the order of your package, which sometimes works, sometimes doesn't, because it gets into a problem if you have many such packages that need to be in a very special order if to work at all. The other problem is that we don't have this offsite storage. We cannot prepare adding something to a hook if the hook is actually not yet there. So for example, if a package would provide a hook in the LaTeX 2E original way, you could only add to this hook if the package was already loaded. So again, you get a dependency on when is something being made available. That was a problem. And so, for example, if you ever looked into the code of hyperref, what Heiko was doing there when he tried to basically adjust all kind of code from different packages to support hyperlinking, he had to figure out, is the package loaded? Is it loaded later on? Because it was loaded after hyperref, so he had to do things at begin document, verify what the status is now, do all kind of changes. It depends on the combination of what kind of hooks have been, what kind of packages have been loaded, and so it's an extremely complicated and messy code then. And this is one of the problems why, well, so often it just made packages incompatible to each other if they were loaded together. And then, as I said, 2E had essentially only a few hooks available, and the rest means patching. And patching means overwriting internals. So what is the result of this? If one package is changing the, say, caption command, and another package is changing the caption command, then the one that comes last wins. Or they need to know about each other, and some of them did. So they were saying, oh, if this package is loaded, I need to do it differently. And the other one would need to say, oh, if the other package is already loaded, I need to do things differently. But this kind of adjustment to each other is very complicated to maintain. And so most of the time it isn't done. And even if it is done, it is likely to break. So as a result, we have a lot of sort of incompatibilities. Packages can only, one of them can be used, or if they are used only in a special way, together in a special order. And furthermore, whenever a package is changing internals of the LaTeX kernel or internals of another package, any fix, any correction, any extension of this internal command, which was not supposed to be changed elsewhere, is going to break the package that is doing the patching. And so, as a result, it was always the case of users not being happy because they wanted to use certain packages together and suddenly it didn't work, or a package starts breaking because we have done a fix in the LaTeX kernel, and so on and so forth. That brings me to the point of something being, well, a maintenance problem that you have in general. There's one possibility for the LaTeX kernel. We are not fixing bugs in the LaTeX kernel, and we are not making improvements in the LaTeX kernel. The result is users are not happy if some of those bugs needs to be corrected. Also, the result is that over time things get more incompatible because packages try to fix those bugs, and then of course you introduce incompatibilities depending on is a certain package loaded, etc., etc. So that's just one situation. The other possibility is we are doing bug fixes and we are making improvements. Now this makes the developers unhappy because we are fixing internal macros that they have overwritten. And then, as a result, their code is no longer working, or everything breaks down because after they overwrite our code again, it doesn't match with the rest of the LaTeX kernel. Well, even if that is not happening, and we are trying these days, whenever we are making changes to the kernel, figure out which package is possibly affected and try to contact people beforehand. It might make users unhappy because once LaTeX is released, we find that we have missed one or the other case. It's just happening, which is one of the reasons why we more or less every half year have a patch level 1 or something, because something got overlooked at the release time. Anyway, until 2.16, we were basically saying we keep the kernel frozen, everything happening in packages. The answer today, or let's say since then, is we are now changing LaTeX, improving it, and we want to get rid of patching. What we want is to have suitable hooks in every necessary place so that packages can add to these hooks, and then we have a mechanism to manage this. So this is the way forward. It still makes developers unhappy because we are still sort of getting after them, patching the internals and making this, changing this. But hopefully, as a result of actually doing it, it's a one-time effort. Because once they are using hooks, we are no longer in the problem of we are overwriting their code, or they are overwriting our code, or packages code between different packages. So from our side, the task basically is we have to understand where patching is being done of internal LaTeX commands by packages, why this is being done, identifying suitable places where hooks can be introduced, and then making sure that packages one after the other is actually starting to use hooks rather than overwriting internal commands. Just to give an example here, the internal command @footnote text is currently being patched by 7 packages in 4 different places. You can imagine how well those packages work together. They could work together, some of them, but they don't, simply because they are always just overriding the command. Okay. A little bit of how this mechanism of the new mechanism is actually working. So basically, a hook is a point in the code with a name, and a hook can hold arbitrary many pieces of code. Each has a label, a name. And these labeled code chunks can be then ordered and removed from the hook. The labels themselves, the hook names, they have to be unique across the document. So basically, each hook has a unique name, and yet there can only be one such hook with a certain name. Within code chunks of a hook, the labels have to have distinctive names so that they can be identified. If you use a name twice, then basically you refer to the same code chunk in the hook. And so, for example, adding something twice with the same label name would just append to the code chunk. The defaults. By default, if you have a new hook, it is empty and it does not alter the typesetting. If it is being inside code, it is not completely transparent. If you have code that tries to look ahead in the input stream, For example, in tabular environments, TUG is scanning for the next @ sign at a very low level. And if there's a hook in the way, then it stops at this point. So there, for tabulars, there has to be special use hooks. As I said, there need to be something for full transparency to have a special hook usage in tabular environments. What is sort of the important points? Hooks are fast. Packages can have and add hooks to the code of the environments or whatever they define. It doesn't hurt the processing. If the hook is basically empty, then it is sort of minimal overhead. It allows for coordination with other packages. It allows for customizations by users, by classes, by whatsoever. And it avoids the need for this internal patching if the right kind of hooks are actually being provided. As I said, you gain in compatibility. Normally, different hooks can add, different packages can add to the same hook, like say for example, the very famous begin document hook. All kind of packages add to this. And the idea is normally doesn't make a difference in which order stuff goes into this hook. But of course, there are cases where it does make a difference, and this is where the package, the hook management offers methods to structure what is inside a hook. So for example, it is possible from the outside to define rules that certain hook chunks are being in a certain order. It is even possible to remove hook chunks or replace them with some other code. So there are management possibilities. These management possibilities can even be provided before the data or is actually added to the hook. So if we have two packages that write to the begin document, we can say the code from one package should be before the code from the other package, even if none of the packages have been loaded yet. And if they never been loaded, that rule doesn't apply. But if they get both loaded, the rule kicks in. So there is a possibility to have the structure that is necessary, the rules that are necessary to be defined by a class, by a package, or even in the preamble if you need to override something. But basically you can define it without waiting that everything is already there. You can sort of state what needs to be there if it comes to this point. This is the anticipated support. Okay, I'm not going into details about syntax and so, but I give you a couple of examples, and I think you can at least get the idea of what this works. So, for example, here we have a command called add to hook next that adds some code to the ship out / background hook the next time that one is invoked. And as you see, it's basically a piece of picture code. The ship out background hook is putting a picture behind the pages, so you can place something on the next page. And what this does is this. On the next page, in this case the next slide, the graphic is being added in the middle of the page because the 0 point of this picture environment is the top left corner. So next page is gone. Another example is fixing packages or fixing code if a package gets loaded. We have a class, or class file in this case. We have a class, Dean brief from Germany that is, I don't know, from the early 90s or even older. Last time changed in 2000. And it is no longer compatible with LaTeX because it is missing a begin group, or it adds one too many. So what this does is it adds code to the file after the file deanbrief.cls is loaded. That's the first hook. It is executed after this file is loaded. Then this first aid needed, this is just a test to make sure that we are actually patching the class the way we think it is. So if it is still the class from 2000, we patch, otherwise we don't. So this is a private command that we have in the LaTeX, basically. And then comes the actual patching, which is we add to the hook called environment env/document begin. So at the beginning of the document environment, we add another begin group because that one is missing. So in other words, this code sits there and waits for, first of all, the Dean class being loaded. If it is not loaded, nothing happens. If it is loaded, it prepares for the environment, the document environment, to get another begin group at the beginning. As a result, this class continues to work with the current LaTeX without ever touching the class. This is another example, completely different. If you are in the need to get more words into your document because you're only allowed to have 4 pages in your proceedings article, or 10 pages or whatever, you can try to make every paragraph run as short as possible. So what I do here is basically say at the beginning of a paragraph, set the looseness to -1. And that's the first hook. It's adding to the begin paragraph hook. And the second command is basically, yeah, thank you. The second command is basically to say, oh, I thought I have another half an hour because we're waiting for break. No? Oh, okay. The second command is basically just if you want in a certain situation to avoid this happening, I offer a command which adds to this paragraph begin hook once a looseness 0. So this is the way I cancel it for one time. What you shouldn't do, just as a side remark, try the same as +1. Make your document longer, because that happens to have then always just one word at the end of each paragraph, which is probably not a very pleasing version. So this is another example. It comes from the package called structured log, which offers you extra lines in the log file so that you can easily find where a file is started and where a file is stopping. It's using a little bit of LaTeX 3 programming layer code, but that is not important. The important is before a file is loaded, and this is a hook which is run for every file being loaded with input or something similar. It runs this file hook log recording start command, and for every ending of such a file, it runs the stop command. Now you might wonder why this is sort of wrapped in another hook. The reason is very simple. When the package is loaded, and this is inside a package, and we would just say add to hook file after, then at the end of the package, the package file ends. And then we would have a stop without having a start, because the start is done in the same. So this is basically saying, on the next hook, install the thing that I really want. So when it goes out of the package, it installs the stop and not already inside the package, because then it would be executed. So this is just sort of delaying it. This is an example of code reordering. So basically this says the hook called showkeys, sorry, the hook is begin document, and the label called showkeys, which is installed by the showkeys package, should always come before the label called nameref inside this hook. So when both packages are loaded, they both store stuff in the begin document hook, and they should do it in this order, or the execution should happen in this order, okay? If only one is loaded, nothing happens. If none is loaded, also nothing happens, and the code is thrown away at the begin document. This is another example coming from our test suite. You might know that these days LaTeX not only announces information about itself at the beginning of the log file or beginning of the run, it also says what version it is, and so at the very end. That was a request by Carl Barry. He wanted to have that at the very end, because at the beginning it's often not visible if you run from the command line. We added that some time ago, and it messed up all our tests, because suddenly at the end of the document we got a version number of LaTeX inside the test output. And so whenever we change the version of LaTeX, all our tests need to be updated, because we're comparing the log results. So we wanted to get rid of this nice new functionality. And so what this code here does is basically saying, in the hook end document info, if there is a code chunk called kernel test mode, it voids, it removes the code chunk called kernel release. So basically all the test suite needs to do is to install kernel test mode in that hook, and then it drops the code that we have normally in this place. Okay, final thing, and I have still 15 minutes. Yes, okay. No. Okay, so jumping over to what are sockets. So these are two sockets. One is from my home, the other one not quite. What are plugs? Plugs are on the right, you see. There's one lying on the floor, and the other one is inside the hook. And what's the characteristics? Well, in contrast to hooks, you can have only one plug inside your socket, right? So you can exchange them, but you cannot add several in the same place, right? So if we translate that to LaTeX, a socket defines a place in your code with a name where we can plug in code. And we can remove that code and plug in some other code. But it's not that there's only one plug that we put in, one piece of code that goes in there. Why would you want to do something like this? Basically, when you are having algorithms or something where you change from one processing model to another one, but there can only be one algorithm or one piece of code being there. So for example, we will have plugs, or we have plugs, for tagging code, which is sitting in various places, and the tagging code can be turned off, or the plug can be removed, but there is not something like a hook where many different packages would add to this point. So, the concept is somewhat similar to what is done with hooks. Every socket has a name. The name has been unique, plug names have to be unique per socket. So for example, every plug by default has a socket called no operation, no op. And this is the one that is normally stuck in. So it is not doing anything. If a socket has an argument, then there's an exception. The default for this socket is, the plug for the socket is called identity, and it is just executing the argument without braces, because that's the most common need for something like this if a socket is used for configuration, that the argument is actually being processed. Question: why and when do you use hooks? When do you use sockets? Basically, hooks are intended for things where you have a place where general configuration can happen, and you expect that different configurations make sense at this place in parallel. That's the idea. As I said, I mean, if you think about the model of something like begin document, at begin document, you have certain finalizations happening, and that can happen in several times for several different things. In contrast to that, sockets are intended to be used in typical one-off. It's on or off. If you have need for very tightly control, and if you are, as I said earlier, have different processing models that you want to support. For example, in page layout, you have the idea that footnotes can go below bottom floats, or they can go above bottom floats. That's a style decision. It requires different algorithms for processing, but there can be only one of them. You cannot have both at the same time because it's a different kind of model. I mean, at any one time. So this is a typical case for a socket. You stuck in one of the algorithm, either this one or that one or a third one, but you cannot stuck in several pieces. So that's a socket part. And now, final advice. It's very useful, and it will help with situations like cleaning this, or answering the question of what should package owner do for tagging. What we are going to provide is to provide sockets for certain situations regarding tagging. For example, for, say, tabular processing. There will be a number of sockets to get tabular processing right. These sockets are used in array and tabular X, and so on and so forth. And they should be usable in, I don't know, tuple X and whatever other package is there. So basically the idea is that we are providing the basic sockets that need to be inserted in and reused in such packages as well. We might find that we haven't got everything right for an extended package, but basically the idea is that this is actually not much more than adding those sockets after the models that we have already shown in packages we have made tagging aware in similar packages. Same then for TUG processing or for float processing and so on and so forth. So that's where sockets come in, and where the tagging support would probably end up being in a standard. What shouldn't happen, and this is why I show this picture, don't go overboard. I've seen people trying to use hooks in various ways. Or, for example, using hooks to change configuration. So doing things like adding something to a hook and then later on removing it and adding it again and removing it. That's technically possible. But the idea of something like hooks or sockets, it's configuration for the document. It's not normally the idea of process. And if you do it sort of a million times in a single document, you will get a time penalty for it. The idea is to configure once and only change if absolutely necessary. So this is what I meant here. And now we come to the time where
checked says 0.
Yeah, okay. So basically, I'm done here, and I expect it to be done here. There's a lot of more slides for people who want to look about the actual technical side, but I leave that to this, and here's the documentation that we currently have. Thank you very much.
Okay, thanks a lot. I saw Didier raising his hand.
But we are out of time, so Didier, no.
Your terminology is all wrong. I'm just kidding. You should have called those socks and feet. Well, anyway, I have 2 questions.
That's a nice version.
And the hooks should have been called templates, obviously. A question about hooks. You mentioned the fact that it's possible to add an ordering rule, for instance, when even before the corresponding chunks are in there. My question is, what happens in the opposite situation? For instance, if you add a rule and the hook in question is already in an inconsistent state with respect to the hook, to the rule, will that be corrected?
It cannot be an inconsistent state because the state is only finalized at begin document, let's say. So the rule will be obeyed if you have 2 rules that are in conflict with each other. Actual rules. I mean, if you say a package code chunk A should be before code chunk B, and somewhat later some other package says no, B should be before A, you get an error message that you have conflicting rules. But as such, without a rule, there cannot be a conflict.
So you mean that it's not possible to add chunk A and then chunk B, and later on say, oh, in fact, no, I have a rule which stipulates that chunk B should always be here before chunk A? That's not possible?
No, what I'm saying is, if you say add to hook chunk A, and at some point you say add to hook chunk B, the order or the final execution is not determined.
Okay, I see.
It is in fact technically determined that by default it goes in the order it comes through. But if a rule comes and says change me to some ordering, it does that.
Oh, okay, that's okay.
That's basically it goes into storage and waits for a final decision, and the decision is only made once or when another rule comes along.
Okay, fine. Second question is about the sockets. When we were exchanging about the terminology on the YouTube channel about the templates, David Carlisle mentioned the fact that templates are actually sort of named signatures, I quote him, for allowing for interchangeable implementations. So isn't that sort of the same thing as sockets and plugs, in the sense that if you plug in one particular implementation for a specific interface, and then the only thing that you can do afterwards is replace the implementation with another kind of implementation, but for the same interface?
Yes.
So, so does it mean that
no.
templates are implemented in terms of sockets and plugs, for instance?
No. There's actually documentation on, it's now gone, but never mind. Sockets are the low-level stuff. No configuration offer on sockets. Sockets is really just code. You plug in a piece of code, you plug in another piece of code. Templates, if you like, have very much in common with sockets, except that the main machinery behind it is the configuration possibility throughout key values. So you turn a template, you take a template and you produce an instance, which is a setting of all the key values that the template supports into a specific set. Well, from that point on, it behaves like a socket, if you like. It is just this piece of code that is fast executed. But it's for the big stuff, and the other one is for the fast, low-level stuff.
Okay. Boris, something from YouTube?
In YouTube, they have David and Chris who are answering questions.
They can ask their questions, but it doesn't make sense to go on here, I would say.
Okay, I think everything else Frank has to say will be a dinner, will be a lunch toast today. There was another question. Oh yeah, Martin.
It's obvious to me that LaTeX has grown into the operating system on top of TeX. Don't you think it's time that we have a distinction between user mode and kernel mode in the TeX engines? The problems you describe remind me on the early days of my programming personal computers, and we don't have that distinction then. So you could do in user mode anything you would like, and that's what we have in TeX now.
Well, yes, yes and no. I mean, there's a we don't have very good sort of separation. That's for sure. But I mean, LaTeX always tried to make a certain level of separation by initially making a certain letter being not accessible and stuff. It can be overwritten, just like you can go into kernel mode if you know how to do it from on operating system stuff, but you cannot do it that easily. Yes, it's not as good as you could think of, but I mean that's not part of the tech model. So what would you want to do? Change the engines? Yeah, well.
Yeah. I just want
Feel
to
free to provide. We would use it, but the problem is they need to be in all engines. Need to be there. Yeah. Yeah.
So,
you say so.
I just want to add to the discussion, that I think we should just kill 80% of packages and move 10% of packages into the kernel, and we will have 10% of the packages remaining, and that's the packages we should care about. Because the abundance of like stupid packages, unmaintained, doing 5 packages the same thing, that's just not a maintainable environment. And I know it doesn't have a solution. I know you'll tell me that. You are right. I just think that we should try and really do something like that. Otherwise, we will never be flexible, never do things well, always deal with incompatibilities, always deal with stupid user issues that we cannot resolve, and we just have to tell the user, sorry, the class maintainer of this class was stupid enough to use a package that was maintained by someone who quit 5 years ago, left no documentation behind. And that's the situation in which we are, and it really sucks. Sorry.
Yeah. Part of that, to a certain extent, I agree with you, and this is part of what we are currently trying to do and what is necessary. I mean, one of the reasons why I wrote with Ulrike and others the 3rd edition of the LaTeX Companion is to get a sort of a base set of packages again, sort of, if said, moderated in some sense, and the same is what we are doing. With the tagging project is actually I'm roping in more and more packages into the kernel, and getting a classification. On the other hand, one of the reasons why tag is this year we can celebrate 30 years of TUG and 40 years of LaTeX. That's one of the oldest software still around, and one of the reasons is that we actually had this kind of development. It's always had a problem to go out of hand. That was the reason why we introduced TUG back then, because it was the same kind of problem. We had too many different flavors that didn't work together. And for the same reason, I think what we are currently doing with this list that Ulrike showed is trying to get certain things sort of into a normal state again, and also trying to get a reduction in packages. But that doesn't mean that it should be fully stopped, because that is also the lifeblood of what LaTeX is all about. And if you try to kill that, you get to tools that have long been gone for the same reason, because they didn't allow for evolvement.
Okay, thanks. I think these were perfect concluding remarks.